Let us quickly see the working principle of a brushed DC motor. I explained comprehensively in a simple way. The principle behind is when a current carrying conductor is placed in a magnetic field, it experiences a mechanical force in a particular direction. Let us take a simple elementary model of a DC motor. In this model, one single turn of conductor is placed between two opposite poles of the magnet, the south and the north pole as shown. If we start supplying DC to the commutator system, the current starts flowing through the coil as shown. The positive of the battery is connected to the left side of the conductor and negative is connected to the right side of the conductor. See the direction of the current flowing. From the left side it goes inwards and from the right side it goes outwards. The conductor is now carrying current and placed inside a magnetic field. Both ends will experience a mechanical force acting on them. The direction of this force can be determined using a Fleming left hand rule. If we point the forefinger or the first finger towards the magnetic field and point the second finger or the middle finger towards the current, then the thumb gives us the direction of the motion or the force acting on the conductor. So if we apply this rule, then the left side of the conductor experiences a downward force and the right side of the conductor experiences the upward force. Due to this upward and the downward forces, a torque is produced which tend to rotate the coil in the anti-clockwise direction. After rotating 90 degrees, the coil comes in the vertical position with respect to the magnetic field. Now there is no current in the coil as the brushes rest in between the two commutator segments. But due to moment of inertia, the turn continues to rotate anti-clockwise and comes in the horizontal position again. But note the position of the conductors are now interchanged. So we can conclude in this model that whichever conductor comes near south pole experiences upward force and whichever comes near north pole experiences a downward force, and due to these two forces the single turn continues to rotate until the battery is disconnected. The practical DC motor rotate with the same principle as this elementary single turn model. Though practical motor will have multiple turns of armature coil and instead of two poles there can be multiple poles. This is how the simple DC motor looks which we use in the toys etc. This is the shaft, this is the body, these are the terminal to which we supply the DC. Let me dismantle this DC motor to show you the internal parts. This is the steel frame with the permanent magnets. These are the brushes to which the external DC supply is connected. This is the commutator which makes a connection between the brushes and the rotating part. And this rotating part consists of an armature coil and the laminated core. Note, this is a laminated core, that is, it is made up of layers to minimize the eddy currents, which we will learn in the higher classes.